This is Eyes Only. Declassified operations. Forgotten programs. The things they don't teach in history class. Today we're covering something different. Not a Cold War black op or a buried government experiment. We're talking about something happening right now. Something you can see with a telescope if you know where to look. And depending on who you ask, it's either the most exciting astronomical discovery of the decade, or something far more concerning. This is the story of 3I Atlas, July 1st, 2025. The Atlas Survey Telescope in Rio Hurtado, Chile, picks up a faint, fast-moving object. Within hours, astronomers realize this isn't just another rock from our solar system. The trajectory is all wrong. The speed is all wrong. This object came from interstellar space. They designated it 3I Atlas, the I standing for interstellar. The third confirmed visitor from beyond our solar system, after Oumuamua in 2017 and Borisov in 2019. But unlike those previous visitors, 3I Atlas would become something far more controversial. NASA quickly identified it as a comet based on telescope observations showing an icy core surrounded by a coma, that glowing halo of gas and dust. Standard comet behavior. Case closed. Except it wasn't. E-Atlas is hauling ass through our solar system at over 200,000 kilometers per hour. That's about 61 kilometers per second. For reference, that's significantly faster than the previous two interstellar visitors. Its trajectory is hyperbolic, meaning it's moving too fast to be captured by the sun's gravity. It's just passing through. The Hubble Space Telescope estimated its nucleus diameter somewhere between 440 meters and 5.6 kilometers across, most likely less than a kilometer. Not massive by cosmic standards, but not small either. James Webb Space Telescope observations in August revealed something interesting. E-Atlas is unusually rich in carbon dioxide and contains relatively small amounts of water ice. It's also emitting cyanide gas and atomic nickel vapor at concentrations similar to solar system comets. On October 3rd, it passed within 28 million kilometers of Mars. Mars Reconnaissance Orbiter's HiRISE camera captured images showing unusual jet patterns. On October 29th, it reached perihelion, its closest approach to the Sun, at 203 million kilometers. Unfortunately, from Earth's perspective, it was directly behind the Sun at that time. We couldn't see what happened at the most critical moment of its journey. It re-emerged in early November. That's when things got weird. Dr. Avi Loeb, a theoretical astrophysicist at Harvard and head of the Galileo Project, which investigates potential evidence of extraterrestrial technology, has been publishing a steady stream of scientific essays questioning whether 3I Atlas might be more than just a comet. He's identified 12 anomalies. Let me walk you through them. 1. The object's trajectory is aligned within 5 degrees of the ecliptic plane, the plane where all our planets orbit. For a random interstellar object, the statistical likelihood of this alignment is about 0.2%. That's not impossible, but it's unusual. 2. During July, August, and November 2025, it displayed a sunward jet, what astronomers call an anti-tail, pointing toward the sun rather than away from it. Natural comets don't typically do this, except under very specific geometric viewing angles. The observations of 3I Atlas appear to rule out those geometric explanations. 3. Its nucleus is approximately 1,000,000 times more massive than Oumuamua and 1,000 times more massive than Borisov, while moving faster than both. Combined statistical likelihood, less than 0.1%. 4. The timing of its arrival brought it within tens of millions of kilometers of Mars, Venus, and Jupiter, and conveniently made it unobservable from Earth at perihelion. Combined likelihood 0.005%. 5. Gas analysis shows much more nickel than iron. That's unusual. Industrially produced nickel alloys on Earth have similar ratios. 6. The nickel to cyanide ratio is orders of magnitude different from typical solar system comets. 7. It originated from the direction of the galactic center, one of the densest star-forming regions in the Milky Way. 8. Non-gravitational acceleration has been detected, meaning something other than gravity is affecting its trajectory. For comets, this is usually explained by gas jets acting like tiny rocket engines as ice sublimates. But the magnitude of the effect is raising questions. 9 and 10. Post-perihelion images from November 5th showed no clear cometary tail, despite calculations suggesting it should have lost over 13% of its mass. By November 8th and 9th, massive jet structures appeared, some extending over 3 million kilometers. 11. Despite losing significant mass, 3I Atlas remained intact as a single body. Many comets fragment when passing close to the Sun. 12. The jets maintain tight collimation. They're not smeared by rotation, as would be expected from a tumbling natural object. Most recently, on November 20th, new images revealed sideways streaks, creating an X pattern with the tail and anti-tail. Observers are debating whether these are real structures, satellite artifacts, or evidence of smaller objects being released from the main body. Loeb has been careful to hedge his position. He's not claiming 3I Atlas is definitely alien technology. He's saying the scientific community should seriously consider the possibility, and not dismiss it out of hand based on assumptions drawn from our limited experience with solar system comets. His core argument: for decades, comet expertise has been built on studying icy rocks from our own solar system. But humanity has launched technological objects into space, the Voyager probes, the Tesla Roadster SpaceX sent into orbit. These are now interstellar artifacts, or will be. Other civilizations billions of years older than us could have done the same thing. Would comet experts recognize such an object if they saw it? In January 2025, the Minor Planet Center initially identified SpaceX's Tesla Roadster as a near-Earth asteroid before realizing their mistake. Loeb uses this as evidence that even obvious human technology can be misidentified. NASA is having none of it. Tom Statler, NASA's lead scientist for solar system small bodies, stated bluntly, "It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know." Other astronomers have pushed back hard on Loeb's anomaly list, arguing that each point has conventional explanations and that his statistical analyses are flawed or misleading. The debate has become heated. On one side, mainstream astronomy insisting this is just an interesting but natural interstellar comet. On the other, Loeb and his supporters arguing the scientific community is reflexively dismissing possibilities that deserve investigation. Here's where it gets interesting. There are claims circulating that 3I Atlas may have served as the trigger for the largest planetary defense exercise ever conducted, possibly still ongoing. The European Space Agency released a statement describing their monitoring of 3I Atlas as a rehearsal for planetary defense. That's official language. When ESA uses those words, it activates specific international bodies under the United Nations Office for Outer Space Affairs. Some observers have noted patterns suggesting coordinated information control. Scientific data releases appearing synchronized, certain observation results being withheld, and what they describe as a media blackout following the Mars flyby in early October. NASA data from multiple Mars orbiters, including instruments on Mars Reconnaissance Orbiter, MAVEN, Mars Express, ExoMars Trace Gas Orbiter, China's Tianwen-1, and the UAE's HOPE Orbiter, has not been fully released yet. Loeb himself has commented on this, asking why there hasn't been more data shared from the various spacecraft that had clear views of 3I Atlas during its closest approaches to Mars and Venus. Is this legitimate operational security for a defense exercise? Standard scientific caution before publishing results? Or just normal delays in processing and analyzing massive amounts of data? We don't know. As of today, November 23, 2025, 3I Atlas is visible in the eastern pre-dawn sky in the constellation Virgo. You need at least an 8-inch telescope to see it. It's faint, around magnitude 12. ESA's Jupiter Icy Moons Explorer spacecraft is actively observing it right now, through November 25th. Because JUICE is catching it so soon after perihelion, it likely has the best view of the comet in its most active state. Hubble is conducting ultraviolet spectroscopy to determine gas composition and sulfur to oxygen ratios. James Webb is scheduled for follow-up observations in December. On December 19th, 6 days before Christmas, 3I Atlas will make its closest approach to Earth at 269 million kilometers. That's still very far away. No threat to our planet. Then, in March 2026, it will pass within 53 million kilometers of Jupiter, where the Juno spacecraft may attempt observations. After that, it leaves our solar system forever, continuing its journey through the galaxy. So what is 3I Atlas? If you ask NASA and most of the astronomical community, it's a comet. An unusual one, sure. An interstellar visitor with some interesting properties that we're still trying to understand. But fundamentally, a natural object composed of ice and rock that's sublimating as it passes near our sun. If you ask Avi Loeb, it's an object worthy of serious investigation that might be something more. Not definitely alien technology, but strange enough that we shouldn't dismiss the possibility based solely on our preconceptions about what comets should look like. And if you ask the people tracking the coordination between space agencies, the timing of data releases, and the official language being used, well, they're asking questions about what's really being observed and why information seems to be carefully controlled. Here's what we know for certain. This object came from another star system. It's passing through our solar system right now. Multiple government space agencies and dozens of scientific instruments are watching it closely. It's displaying behaviors that are generating genuine scientific debate. And depending on how the next few months of observations go, we'll either have a fascinating but conventional interstellar comet to study, or we'll have some very uncomfortable questions to answer. The raw observation data exists. The images are being taken. The spectroscopy is being conducted. Eventually, the full scientific analysis will be published and peer-reviewed. But right now, in late November 2025, we're in that uncomfortable space between discovery and understanding, between observation and explanation. iAtlas will make its closest approach to Earth on December 19th. If you have access to a decent telescope, it's visible in the pre-dawn sky through late November. JWST observations will resume in December. Juno's potential Jupiter observation window opens in March 2026. The data is coming. The analysis is ongoing, and the debate is far from over. Whatever 3I Atlas turns out to be, whether it's the most interesting comet we've studied or something far stranger, we're watching it happen in real time. This has been Eyes Only.